Okay, chapter 5. Scaling triangle, isosceles triangle, equilateral triangle. So different ways of classifying triangles. And what's key here is that we understand that we're classifying the triangles. We're not naming them. Naming them would be like triangle ABC. Okay, that's naming the triangle. Classifying the triangles means what kind of triangles are there? Basically by their sides and then by their angles. So there's two types of classifications. You have to give two names of the classifying sides or angles. Okay? So if none of the sides are the same, that's scaling. If you have two sides, that's isosceles. And if all three are the same, it's equilateral. Then you have acute triangle. All three angles are less than 90. A right triangle, you have one 90-degree angle. And obtuse, you have one angle above 90 degrees. And then equiangular means they're all the same, which they are all 60 degrees, because there's 180 degrees in a triangle, so you have 180 divided by 3 is 60. And then we have exterior angles, and we have interior angles. Okay, interior angles all the way up to 180. That is the triangle sum theorem that we've been talking about all semester. So they all three add up to 180. So now we can just say that's the triangle sum theorem. And then we'll learn about the exterior angles here in a minute. Okay, classify by sides and by angles. So number one, by sides first, that's isosceles. There's two that are the same. Learn how to spell it. And then by its angles, well, 90 degrees means right. So it's isosceles right triangle. Number three, this is obtuse. It's bigger than 90, so that's going to be an obtuse by the angle. And then there's no markings for sides, so this would be scaling. So obtuse scaling or scaling obtuse. We usually give the angles first. So number one would be right isosceles, and number three would be obtuse scaling. So just for practice, number two, all three sides are the same. If we do angles first, that's equiangular. Oops. And equilateral. And number four, again, this is scaling. None of the sides are marked. And they're all acute. So acute scaling triangle. Okay, now let's graph these and see what we get. So A is at 2, 3. B is at 6, 3. And C is at 2, 7. Okay, so what do the instructions say? Classify it by its sides and then determine whether it's a right triangle. Okay, well, the side lengths we can count 1, 2, 3, 4. That's 4. This is 1, 2, 3, 4. Okay, so it's isosceles. And is it a right triangle? Well, we can see definitely that a horizontal and vertical line forms a right triangle. So yes, it's a right triangle. Next. All right, so again, we got a graph. A is at 1, 9. 1, 4, 5, 6, 7, 8, 9. B is at 4, 8. 4 and 8. C is at 2, 5. Okay, so count if you have to. Now the question is, we have to classify it by its side lengths. So we need the distance formula. So let's do the distance from A to B. So distance formula again, you have to know it. So A to B, so we're going to do x minus x and y minus y. And we get AB is negative 3 squared and 1 squared. So when you square all those, the negatives go away. That's 9 and 1. That's the square root of 10. Now you don't need to simplify it, because if it matches something else, then you're good to go. I think it might match B to C, so let's do B to C. So that's x minus x and y minus y. And we get 2 squared plus 3 squared. So that's 4 plus 9. That's the square root of 13. All right, well, that doesn't match. So that means we got to try a to c. All right, so the distance from a to c, 1 minus 2, and 9 minus 5. So you should be fast at this by now. That's negative 1, and that's 4. So that is, 1 plus 16, or the square root of 17. All right, so you don't need to simplify any of these. None of them do simplify. But all three distances are different, so that means it's scaling. Now, how do you know if it's a right triangle? Only if you have opposite and reciprocal slopes. So I think A to B and A to C, that's obvious that those are not 90. If those were 90, oops, let's get rid of that. If those were 90, then it'd have to be almost like that. Those are definitely less than 90. So we're not going to try that, but we are going to look for, let's do AB and BC. We got to check those slopes. So the slope, M, of A to B, rise over run, we go down 1 and over 1, 2, 3. So down 1 is negative and over 3. Now what is the slope from B to C? So B to C, we go to the left 1, 2. So that's a run, negative 2, that goes on your bottom. And then we go down 1, 2, 3. So that'd be positive 3/2. All right, well, they're opposite signs, but they're not opposite reciprocals. All right, so it's not a right triangle. So no right triangle. Okay, find the measure of angle 1. All right, the triangle sum theorem says that they add up to 180. So 180 minus 78 is what? 180 minus 78 is 102. Subtract 31. Or you could have said 78 plus 31, and x is the angle 1 equals 180. You could have done it like that. Okay, 102 minus 31 is 71. So the measure of angle 1 is 71 degrees. Let's see, did we check everything? Classify the triangle by its sides. All right, they're not marked, so this is scaling. All right, so you need to have those two pieces. Oh, wait, did we? Okay, now, this is a right triangle because it has the 90-degree angle. And since that's 90, there's 90 degrees left between those two. So what is 90 minus 38? That would be 52. So the measure of angle 1 is 52 degrees. So there's your two answers for that. Okay, now let's go with the angle of exterior angle. So this exterior angle here. Exterior angle, the measure, let's call it angle 1. The measure of angle 1 is equal to the interior angles added together. Not this one. Don't ever add the one that's included. Okay? So angle 1 is equal to the opposite two angles added together. 64 plus 75. 75. So that's 139. So the measure of angle 1 is 139 degrees. Okay? And if you think about it, I'll go ahead and explain again, like what we did in class. If the measure of angle 1 is 139 degrees, first of all, that's obtuse, and this is an obtuse angle. This is a straight line, which is 180 degrees. So that means this angle in here must be 180 minus the 139, so that's 41 degrees. And if you took the interior angles here and added them together, you should get 180. All right, which means if you took 180 minus the 41, you would get the 139, which is what those two added together are. So the opposite interior angles added together are the exterior angles. Again, the exterior angle is the opposite two angles added together, 2x plus 18 plus 24. So now we solve. Subtract 2x, and 18 and 24 is 42. Subtract the 6, and x is 36. Now 36 degrees, it's 36. Now it says find the measure so we need to substitute it back in. So 3 times 36 plus 6. That's 90, and 18 is 108, plus 6 is 114 degrees. That's the final answer. Okay, since that's 90, then these two added together are 90. So 2x plus 3x must equal 90, because 90 is 180. 5x equals 90 divided by 5, and you get 18. So x is 18. It says find the measure of each angle. So you got to plug 18 back in for x. 2 times 18 is 36, so this would be 36 degrees. And 3 times 18 is 54 degrees. So if you took 90 plus 36 plus 54, you'd get 180. Number 19, same thing. These two added together have to equal 90. Only in a right triangle. And if you're just not sure of that, you could just add all three angles together. 11x minus 2 plus 6x plus 7 plus the 90-degree angle. All of that's going to equal 180. Now watch what happens. If we subtract off the 90, what do we get? We get the first two angles added together equal to 90. Because that's always what's left if you subtract off the angle of the right angle. All right, so what do we have? 17x and a plus 5 equals 90. So now we subtract 5, we get 85, divide off of 17, you get 5. Now, find the measure of each acute angle. So you got to plug 5 in to each of your x's. Okay? So 6 times 5 is 30. 30 plus 7 is 37 degrees. 11 times 5 is 55. 55 minus 2 is 53 degrees. So those would be the two correct answers, and you would need to show all that work. Find the measure of each acute angle. Okay, find the measure of each acute angle and the right triangle. So each acute angle and the right triangle. So we know that we have a right triangle. Okay, we don't know if it's like this. Okay, we don't know the shape of the right triangle. So I'm just going to focus on a generic right triangle. So we know this is 90 degrees, and the other two have to add up to 90. Now what it's saying is the measure of one acute angle, which I don't know what it is, we'll call it x, is 5 times the measure of the other acute angle, we'll call y. I don't know either one. When you don't know something, give it a variable, always. All right, so now let's focus on this acute angle. It says the one acute angle, we'll just say x, is 5 times the measure of the other one. So we want to write it down the way we read it. Okay, the one acute angle, x, means equals 5 times the measure of the other angle, y. Okay, so x is 5y. So I could replace x with 5y. So I'll redraw it real quickly. Okay, and that's y, and this is 5y. Now we only have one variable to deal with. So we have y plus 5y is going to equal 90 degrees. Because we already have a 90-degree angle, and 90 and 90 is 180, so there's 90 degrees left. So that's 6y equals 90. All right, so divide off the 6, and y is equal to 15. Okay, so this one is 15 degrees, and 5 times 15 is 75 degrees. And 75 is 5 times 15. Okay? Another one, the measure of one acute angle. Again, we have a right triangle. So I'm just going to draw a generic right triangle. And it says the measure of one acute angle. I don't know what it is. So x. And it says is 3 times. And then it says the sum of the measure. Sum means sum means plus. We're adding things together. So it's 3 times whatever the total sum is. So it's 3 times the group of things you're adding together. All right. So it's 3 times the total sum of the measure of the other acute angle, we'll say y, and 8 plus 8. All right. So x is 3y plus 24. So again, we can substitute this in for x as 3y plus 24. And so what do we have? We have these two angles added together, y plus x equals 90, and we substitute what y is, what x is down here. 3y plus 24 equals 90. So whenever we substitute, we put parentheses around it, but we don't really need the parentheses now because we've already distributed. So y plus 3y is 4y plus 24 equals 90. Subtract the 24. 4y equals 66. Divide off the 4, and we see what we get. 4 goes into 6 once with the remainder of 2. 4 goes into 26 6 times with a remainder of 2. So that'll be 2 over 4. Your remainder always goes on top, which this means y is 16.5 degrees. So what's x then? So you got to put 16.5 in for y. Multiply it by 3. Okay. 3 times 16.5 is 48, 49.5 plus 24. So use your calculator. So 49.5 plus 24, 49.5 plus 24, 73.5. Okay. There you go. The other acute angle and 8. What they do wrong here. So first of all, we're finding measure angle 1 here. So there's 180 degrees in a triangle. That's the triangle sum theorem. So 39 plus 115 plus, we'll say x for 1, equals 180 degrees. All right. 39 and 115, 144 plus x equals, I'm sorry, that's 154, equals 180. Let's see here. And we subtract 154. So x equals 26. All right, so angle 1, the measure of angle 1 is equal to 26 degrees. So what they do wrong? They put these together, that's 154. Oh, they said it equal to 360. That was what they did wrong. All right, so find the measure of the numbered angle. All right, so these are the puzzles. We come back to these. So I put the even ones on here for practice anyway, so I'm going to do them both. You just have to do the odds, but you might want to save this or at least try the evens as well for practice. They've given us right triangles, so those are 90 degrees. They've given us one other angle, so we ought to be able to find angle 1 and angle 8. So angle 8, this is a straight line, so that's 180 degrees. So if you subtract 40 from 180, you get 140 degrees, so that's angle 8. So you see now why you probably want to do some of the even ones. So in a triangle, you have these 3 degrees here, 90, so there's 90 left out of 180. So 40 and angle 1 have to equal 90, so angle 1 must be 50. And by vertical angles, angle 3 is 50. All right, so we'll go ahead and do angle 2 and angle 4. So if angle 1 is 50 degrees, you got a straight line here, that's 180. So that means angle 2 must be 130. And then by vertical angles, angle 4 must be 130. Okay, so angle 3 is 50. And again, you have 90 degrees here. That leaves 90 degrees left between the two of these. So 90 minus 50 is 40. So angle 5 is 40 degrees. And if angle 5 is 40, that's a straight line. So angle 6 must be 140. And what's angle 7? Well, this is a straight line. It makes 180 degrees. We already have 90 there. So angle 7 must be 90 as well. Okay, face of a bike ramp is shown. Classify the triangle by its sides and by its angles. So none of the sides are the same, so we say that's scalene. And its angles. Well, if none of the sides are the same, then none of the angles are the same. So you have to look at that. It's either right, obtuse, or acute. They're either all acute, right, or they have one obtuse angle. So there's a right triangle. So a right scalene triangle. That's all you have to say. And that's it.